I have a project that I know I'm going to reference in some other videos as well. Uh, this is going to be building a basic alarm system, and I'm going to use a drawer as an example on this, but it can be used for all kinds of different things because I'm going to be showing you the fundamentals to build pretty much whatever type of alarm you want to, whether it be time activated, whether it be a burglar alarm, a fire alarm, whatever it be. The general gist behind alarms is pretty much what I'm going to show you in this video. So let's start looking at how we can figure out what's going on and make some noise or flash some lights or whatever you decide to do regarding this. For an alarm, there's pretty much three main states that you're really going to want to be aware of. Disarmed is offline. It's not monitoring anything. It's just dead. Armed means it's waiting for something to happen. It's monitoring, but it's not actually sounding any type of an alarm, or it's not actually making a ruckus. Tripped, it's making a ruckus. It's trying to alert you. It's trying to whatever it be. It's trying to make some type of, trying to draw attention to itself once it's tripped. There's different modules that we're going to talk about. The control module can be separated, but the central or main module, and possibly included in that, is the control module. I am going to include them on my demonstration here as well, but I will be talking about how there's differences in what they're controlling. But it's the main and central module's job is mainly to keep track of the state of the alarm, while the control module's job is to modify the status of the alarm. And that deals with your states that we talked about previously. Are we dealing with offline, armed, tripped? What are we dealing with on that? There's also sensing, scanning, or detection modules that are basically, those are your zones. That's where it's trying to figure out what's going on and doesn't need to alert you. That's the module that will handle that. What you hook into that module is up to you, and that's the reason why I discuss this as modules, to hopefully make it a little bit easier to understand the different points behind them. Now, tripped, sounding, or alerting, that module is the one that's going to have everything that tries to get someone's attention, whatever that be, whether it be sounding, whether it be flashing lights, however it's trying to alert you. What it does when it's been tripped, that's the module that you need to look at for that. So let's start taking a look at some of the examples on wiring stuff up. So this is the main or central module for our alarm. And a few things to point out on here is this guy would be done by the control module. This is the main arm and disarm switch. And down here, this would be inverted. Some of your circuits, you're going to end up inverting them for different reasons, because this would make your alarm be working on a normally open circuit and activating when it closes, and you generally want it to be opposite. You generally want it to be normally closed and activating when it opens. So this is the drawer, basically. This is a switch. So once the door's in, you've pushed it shut, and that's that way. So in our case, the switch came on when it comes out. So basically, you would just have it to where it turns on when it's in, but you would invert that. And over here, this is kind of what we used for the control module portion, part of it. This would be more the alerting module. The triggering module would be here. So these guys we're going to look into a little bit more. So for it to arm, we would hit this switch up. For it to disarm, we would flip it down. And we can add more complex systems on our control module, but that's one of the things the control module does. Plus, it would also handle disarming it, which would be this little white wire here. It would create a momentary break if it's already sounding. Then it would need to break that. So, right there we are armed. And then as the door opens, it sounds the alarm. Even when the door closes, it does not stop until this little white wire comes disconnected momentarily. Then even once it's reconnected, then it doesn't go off again. So that's why you'd need the momentary break. So those are the spots where we're going to have interfaces to talk about. We're going to talk more about this on another, whenever I redo this board, and we're going to talk a little bit more about different things that we can do for sounding alarms and how we can do things, really differently if we want to. But this guy here, so that's something too that you will do on the control modules. You'll manipulate this, and you will manipulate breaking of that. And sometimes you may have like some type of an electronic code that has to be done for that. But that's the bottom line behind the central and control modules. That's the general gist for your alarm system. I wanted to discuss a little bit more about this relay that we have on here. A relay is basically a power-controlled switch. Across the bottom area right in here, these two bottom terminals are, if you're running power across those, then it's going to flip the switch. So right now without power, we will have power running across these two. If there is power across this coil, if this is energized, this is flipped, so that way these two are connected and this is disconnected. This is always connected to one or the other of these two, but if there's no power here, it's connected to this one. If there is power here, it's connected to this one. So the idea behind this is it is able to trigger, once this is energized, it's going to draw power across here, but then it's also going to feed itself, which is why the alarm stays active once we flip that switch back and it was still sounding. By momentary break on this, on that white wire there, that allows us to give us the to reset it back to a non-trip state. However, that would only work as long as it's not, as long as this drawer wasn't still out, as I mentioned, as long as that switch wasn't still in the other position. These are also useful in inverting circuits as well. You can run a charge across here, and then at that point you can make it to where it turns off your circuit, or you can make it to where it turns it on based on what's here. So they're good for adding that extra layer. Whenever I do say about inverting circuits, that's one of many ways to do an inverted circuit. So now I'm going to set up the example for our, this is more of our monitoring module. And on here I kind of have it as a single zone, you'll see. The concept behind this is that it will always, remember, we're trying to do it with a normally closed circuit, so it's going to have power through it unless there's trouble. Now, what we have set up for trouble here is we have, maybe we've got a light switch rigged that's a trip switch for, the bad guy to flip. We got a pressure panel in the floor, let's say. That could be anything, though. This could be a button that they set something down on, whatever, but just being silly. Pressure button. Okay, pressure panel on the floor. We've got, if they turn on their flashlight, this is a photo resistor. So if they turn on a flashlight and it gets caught in there, it's going to trigger our alarm. And what else did I rig up on here? Oh, and a tripwire too. So if they trip over the tripwire, if this is pulled out, it will also block the current. Now this is all as a single zone because we're only really just blocking one line, and this separate line, each zone would be a separate line from the central module. So in this case, everything here is really on one series circuit because we have the tripwire hooked up in series with the relay, and the relay is checking for the photosensor as well as the key as well as the switch. So what happens here now is, as we, once we have the system armed and it's got the power running through there, it's trying to check to see whatever's trouble. If they hit the switch, it powers my relay over here. These two are in parallel, so either one of these will activate my relay, which is now redirecting the power to where it can't go to back to my central module. So that trips my alarm. And the key does the same thing. A bad guy with his flashlight does the same thing. If he hits over the tripwire, it will also disconnect him. So any one of those things will trigger this module. So whenever you're running anything as well, you want to take a look at the importance of zones. While you can hook up any type of sensor, anything that blocks a circuit can be used as one of your sensors. So you can use motion sensors, you can use just anything under the sun, you can use laser beams, you can use all kinds of stuff. But then I did talk about zones, how I wired everything up on a single zone. And the importance of zones is to identify the location of the trouble, identify the type of trouble. You could even give a difference in the alert based on that. Maybe changing what you might be sending, if it's sending out a text or if it's sounding an alarm. Give a difference in the delay. Even make it to where maybe it requires a certain number of breaks within a certain period of time before it goes to trigger, because these can help to improve the responses. And knowing the location and the type would be very important. Let's say here that you're setting up an integrated alarm system that's going to both run your security and your fire alarm system. So you don't want to go fleeing the place thinking that you have a fire in one direction and you're running right across in front of somebody who's intruded in your house. You'd rather stay in a safer spot. It's good to know what's happening and where. That's part of the point of your alarm. If you have the fire alarm sounding, you want to know the difference between a fire alarm and something that's calling you to evacuate and something that's telling you to shelter in place. Is this an earthquake alarm where you want to dive into your earthquake cavity, or is this a fire alarm where you want to evacuate? Is this a lockdown alarm where it's because of a burglar? Those trigger different responses, and therefore the importance of those zones helps to improve your response on that. Can give you a difference of alert, can tell you, hey, I shouldn't be running towards this. It's in the kitchen, but it's a fire. Don't run to confront it. We need to evacuate, but don't go through the kitchen. Difference in alert could do that. In delays as well, it can also, a difference in delay can be used. Like maybe if you're going to rig it towards your door that you'd have to come through to disarm your alarm, you might want to have it give you a few seconds to be able to disarm it before it starts texting all of your friends in law enforcement to say, hey, there's a burglar, come on over here and arrest them. But something else that definitely should not be ever triggered while you are away might be an immediate response. So the other door or a window being broken out, you might want to have that be an immediate response, while something that's your front door gives you several seconds to go ahead and respond to that. So those are things to consider when you're setting up your zones. That's why a lot of alarm systems have multiple zones. It also allows you to say, this zone is not going to be in service right now. I'm going to ignore that zone because I'm home, I'm not away, but I want the outside perimeter monitored, but I don't want all my internal motion sensors going off every time I move. I just want to know if someone comes in while I'm here. So those are things that you can do with zones that help that. So this is a sample of different options that you can do for how you handle the alarm, for the module that handles alerting you, the trip module. So what you have here, if you remember what we did before, we just hooked it up to a buzzer and we said that would be everything there. So basically we're going to put power across a bus as what we're going to do. That's what that buzzer is, and in this case we have the power coming in. Once the alarm would be tripped, it would send power in, and it comes on in and it comes across a bus right here where we have a light hooked up to it and we have a sound hooked up to it, and we could have even hooked up something else to a relay, could have hooked up a siren to it, could have hooked up whatever else we wanted to, and we can just hook up item after item on there. And we can hook up timers in there if we want to as well. If we want to delay something, like say the light coming on, you know, if we want to say here we want to delay this, we could have a delay circuit in here before it gets to that light. But then our other item over here maybe is an immediate sounding, and then the relay maybe goes off immediately as well, and maybe you have a computer hooked up to that, an Arduino that's going to send a text, or a Raspberry Pi that's going to start talking to everything. But that's how you basically do that. You'd have a bus that would power all of these different alarm things, and off of those things, it depends on how you choose. Do you run it on a delay, or do you run it to where it goes off immediately? And everything can have its own delay. You could even have a bus. From your bus here, you could have a different delay that runs another bus, so that way in 10 seconds you have a whole second battery of things going off that all run from that bus. So basically once that alarm triggers, you've got lights, you've got sound, it all runs right across that bus. So if you are going to run anything with more than a small amount of power, more than just a light buzzer or a light LED type light, something heavier like starting up a computer, or even running anything heavier, you do want to run it through that relay. That's for anything heavier, because you don't know how much. Just depends on the alarm as far as what it can support on its main tripping wire. Generally it has a little bit of oomph for that, but if you need more, you want to pull it from a separate source, and that's where that relay can allow access to that separate source and allow you to run heavier stuff. Thank you for watching.